Okay, let's start with the most basic question, which is what is an algorithm? So, an algorithm is a step-by-step process of achieving a task. So, what are these tasks? These tasks can be anything from as basic as like finding a sum of first and natural numbers, or finding GCD of two numbers. It can be anything, or it can be as complex as finding shortest distance between 2 points in a graph, or it traversing through the entire nodes of a tree. It can be anything. So basically we have a task and we want to achieve it using a step-by-step process. This step-by-step process is called as an algorithm. Hey everyone, this is Chiranjeevi and you're watching the DSA series in Rust. And before getting any further, please make sure you subscribe to this channel for the further episodes. Let's start with writing a basic algorithm. So that basic algorithm is like finding the sum of first and natural numbers. Yeah, this is pretty basic, but we have to start with something basic to have a strong foundation. So I am opening my terminal. I use git bash. So I think now you can see this. Now I am going to desktop. And now I'm creating a directory here using mkdir command, and I'm calling it as DSA. So now I'm getting inside this DSA folder, and now I'm using code space dot to open my VS Code. Okay, now we don't need this anymore. Let's close this. Now we are inside DSA. Now I am creating a new folder inside this, which is called as 01 basics. So inside this I am creating a file, Rust file, which is sum underscore n dot rs. So this is our file sum n dot rs. In this we are going to write a program to find the sum of first and natural numbers. So the basic rule for Rust programming is first we need to have a main function. So let's write this. Inside this main function, what we can do is we can ask user for an input to give n, or we can hard code the number. Let us take user input and continue from there, and the user gives the number n, what we call we have to find sum of numbers from 0 to n, and that is our concept, that is our task in this video, and that is our algorithm right now. And for that we need to take input from the user, for which we need a variable let mute n, and let's take it as type string first, because whatever we are getting from the terminal we'll get it as a string. So let's take it as string for now, and let's initialize it with this new function. And next what we need is we need to get the access to the terminal, so that we can get the input whatever the user is entering in the terminal. So for that what we need is we need to import a package which is inside the std crate. The module is IO. So this is what we need to get the access to the terminal. So now we need the stdin, and the stdin is a function that is coming from IO module inside the std package. So stdin, this is how we can initialize stdin. And now since we have the access to the terminal using stdin, what we can do is we can use stdin dot read line. Read line is the function which we'll use to get the strings that are inserted inside the terminal. So now we will get the line, but which variable should take this line, which is n. So what we have to do is we have to specify the address of n, and it is, since it is mutable, we have to give the mutable reference ampersand mute n, and we have to specify an expect statement, so that if we don't get any input from the user or something breaks, it will print this line. So expecting a number. Okay, this is fine. So now we have, this should prompt user to this should wait for the user to give input to the terminal, and after that it will store that string inside this n. Now what we want is, we want n as a integer, not just as a string, because if it is string we can't do any computations on it, so we need it as a integer to make computations on it. So for that what we need to do is, we can convert this same n to integer using reinitializing it. So if we reinitialize it with another type, it will convert it into that type. I mean, it won't convert, it will reinitialize it as that type. So now what we have to do is, we have to take the n that we created before and which has the string of the number, and we need to first trim that. So let's say if the user enters spaces by mistake in the front or at the last of the input, let's say if the user is inputting 10, and if the user is pushing some spaces before 10 or spaces after 10, we need to remove those spaces. So for that we can use this trim function, and after trimming that, what we need to do is, we want to convert that string into U32 so that we can make computations on it. So to convert the string to any other type, what we can do is, we can use this parse function. This parse function will convert the string into the type whatever we specified here. We specified here U32, so it will convert it into U32. And we have to also specify an expect statement which will show up if the Rust is failed to parse this into a U32. So what we need to do is expecting a U32. So this will happen only when the Rust fails to parse the string into a U32. Now we have n, which is a number, and we want to find the sum of numbers from 0 to n. So let's write a function for that, and we will use that function here. Let's say we want to write a function called as find sum, and we will pass it the n, and this function will find the sum and it will print it to the terminal. So now let's write this function. So what's the syntax? Fn space the name of the function, which is find sum, and this find sum will have an attribute, will have an argument which is n, so of type U32. And inside that, what we can do is, let's initialize a variable sum. Let mute sum. This will have 0. This is of type U32. So let's have a sum variable which is initialized to 0. This will have the sum of each number. Let's start with 0. We will start with 0, right? We will go on 0, 1, 2 and so on up to n. So when we go through that, what we will do is, we will add each number to this sum. So the sum is keeping the track of the sum up to that number to which it iterated through. So we also initialized with mute because the sum is going to change in the program. So we initialized it with mute. Now what we have to do is, we have to go through all the numbers from 0 to n or n plus 1 if we are excluding the last number. So for that, what we can do is, we have to use a loop. Let's use a for loop, and let's call each element inside this whatever we are iterating through as I. So this I, in what we have to specify it a range or a iterable. So what we have to do is, we have to specify it a range. The range starts from 0 and it goes through the range. We will give it as 2 dots. The first one is the initial number and the second argument is the final number which we want to see. So now how far we want to go? We want to go to n. We want to add n also. So what we have to do is, we have to give n plus 1. So now the I will go from 0, 1, 2, 3 and so on up to n, and it will not include n plus 1 because the ending argument is exclusive. Now inside this for loop, what we can do is, we can add all these numbers to sum. So what this line will do is, if the I is 0, it will add it to the sum. If the I is 1, it will add it to the sum. If the I is 2, it will add it to the sum. This is what happens. It will start from 0 and it will go all the way up to n. So now after this line, we have a sum variable which is having the entire sum value. And what we can do is, we can directly print it here. The sum is and we can give the sum here. Let's save this and let's open the terminal. I am inside DSA and I'll have to go inside 0 1 basics, and now I have to compile this program. How do we compile the program? Using rust c and sum underscore and dot rs. I forgot an exclamation mark here, and let's do this again. And we have a executable file now, and let's run this executable file, and it is waiting. If you can see the program intent, it is waiting for us to give a number. So let's give 5, and it is printed the sum is 15, which is the actual sum of 0 to 5. 0 plus 1 1, 1 plus 2 3, 3 plus 3 is 6, 6 plus 4 10, 10 plus 5 15. So we got the right answer. Let's run this one more time, and let's give another number. Let's give 10, and the sum is 55, which is the right number. Okay, we are done with our algorithm, but the question is this the only way we can find the number sum of first and natural numbers? No, we have another way, and let's see what it is. Let's write another function, fn find sum and underscore. Let's keep 2 here, and let's keep underscore 1 here for the ease, and it will also take n, which is of type U32, and it will also find the sum and it will print it to the terminal. So how we can find first and natural numbers? And if we remember the high school arithmetic, there is a formula called n into n plus 1 by 2, where n is the last number and it will find the sum of natural numbers up to that point. So what we can do is we can use that formula and we can find the sum. So let's create a variable let sum of type U32, which will be equal to n into n plus 1 divided by 2. So this is the formula. Now we have sum and we can directly print it. Println the sum is, and we can give sum here. Just to differentiate, I am giving it as sum from fun1 is this, and sum from fun2 is this. Now let's save it, and what we can do is I'm giving underscore 1 here, and I'm just copying this and pasting it again, and let's give it sum 2 here. So now what we'll do is it will take input, it will get the input from the terminal and it will pass it to both these functions, and both these functions will do their computation, and both of them will print. We can differentiate them from this line, fun1 and fun2. Now let's compile this again. Let's compile this again and let's run this. We have to give input. I'm giving 6, and if I click enter, the sum from fun1 is 21 and sum from fun2 is 21. So both of them are working properly. Now the actual question arises, which function should we use? In the real world scenario, when we are writing an algorithm similar to this, we will have multiple methods to write algorithm, and we will have multiple algorithms in our hand to choose from. So which one should we choose? Here we have to choose an algorithm based on two things. The first one is how fast it can run, and the second one is how much less memory it is taking. The less memory it's taking, the much better it is. So when we have multiple algorithms, we have to analyze them and choose only one of them which is satisfying these two conditions. So we are going to discuss these things on how to analyze an algorithm in the next video. So we will analyze an algorithm using time complexity and space complexity, and we will see all of them in the next video. Please don't forget to like this video if you find it useful, and share it to your friends if you think it will be helpful for them as well, and don't forget to subscribe.